This lesson is on making scatter plots from data in RStudio. And here's the basic idea. A lot of this course is about mathematical modeling, and one of the most basic things you can do in mathematical modeling is to take some set of data and try to figure out a function that describes that data well. And so we're going to start that process. Now, in order to be able to do that, we need some data to work with. And so I want to show you, there's lots of different ways to get data into RStudio, but we've set up an especially convenient way for you. We've put some data sets online in a particular place, and they can be accessed using a single command in RStudio. And that command is called fetch data. So the command will be something like fetch data with a capital D. And I'm going to put in quotation marks inside the parenthesis the name of the data set I want, and one that we've created for you is called income-housing.csv. Now if I enter the command just this way, it will fetch that data, but I won't be able to work with it because it hasn't been assigned to a variable, and you've learned about variable assignment. So what we actually need to do at the start of this line is sort of capture that data into something. I'll call it housing. You don't have to call it housing. You could give this variable any name you want, but I'm choosing housing. So what this line will do is it'll go to the special place we've set up on the internet. It'll fetch this particular data set, and it will save it into a variable called housing. Okay? So you see a command, or you see a printout of some words saying that that's been done. Now, if you would like to see what's in that variable housing, you can of course type its name. That seems a little bit inconvenient. We get sort of this long printout. It looks like there's a bunch of columns, and the columns have names, and there's some numbers in them. If we wanted to see the names of the different columns in that data set, we could say names, and then the name of our variable, which is housing. And so these are all the different columns within that housing variable. And the other thing you can do is if you come over here into the Workspace tab on the upper right-hand side, and if you click your variable, housing, you get this sort of little spreadsheet appear. And it's not editable. You won't be able to change the values in here, but it's a nice way of being able to scroll through and see formatted relatively nicely what your data set looks like. Now I want to tell you how to access the different parts of this data set. So you can see that there's a column called income, and if I wanted to actually access that column, I would type housing $income. The dollar sign means column, right? So this means income column of housing. Oh, and you can see I made a classic mistake. This is good for you to see. I typed the name of the column with a mistake in it. It should have been uppercase I. I used lowercase I, so I got an answer of null, meaning we can't find what you're looking for. Housing capital I income, that gives me the numbers in that column. Okay. Similarly, I could type housing crime problem, and I get a little bit of data back there. Now, with this data now loaded, what we'd like to do is visualize it. And the command you'll use to do that is called plot points. So I type plot points of, and I'm going to type the name of a dependent variable. I want crime problem to be the dependent part of the data, and I want the independent part to be income, right? So I say crime problem tilde income. That means use income as x coordinates, use crime problem as y coordinates. Furthermore, I have to say which variable to look in, right? And we saved this all into a variable called housing. So I can say data equals housing, and I get this graph appearing over here at the right. This is called a scatter plot. Another way I could do the same thing is if I didn't want to type data equals housing, I could type plot points of housing $crime problem versus housing $income, and that'll give me the same graph appearing over here. Now, suppose we'd like to go ahead and fit a function, or not fit, but rather place a function on the same graph. So, we could just choose a function that we think might describe this data and plot it. We'll use the plot fun command, and I'm going to choose the function 38 minus x divided by 3500. I'd like to plot that as a function of x. My x limits will be from 0 to 80,000. I want to add it to the current graph, so I use add equals true. And to make it pop out to the eye, we'll say color equals red. and we can see this function appearing, right? So we've put two things on this graph. We've put a scatter plot of data and then a graph of a function which happens to be a line. You can see that this doesn't match the data very well, but that's beside the point for right now. Let me go ahead and clear the console, and then we can talk about the last bit of the lesson, and that last bit has to do with good scientific style. Good scientific style for graphs includes having very informative and clear axis labels. So if you look here, housing $ income, that's not very informative. So we want to make a really nicely formatted graph that has a good x-axis label, a good y-axis label, a nice title, and so on. So I'm going to show you how to do that. We'll do one more command here. We're going to do plot points of, let's do crime problem as a function of income, but I want income to be in thousands. So instead of 3914 being the first x-coordinate, I want 3.914 to be the first coordinate. So I'll do income divided by 1,000. This comes from the housing variable, so we type data equals housing, and then I'm going to type the x-axis label that I want. And the command is xlab equals, and then I put what I want between quotes. And I think what I will call it is income bracket, and then in parenthesis within that, I will put the units, which will be $ thousands per year, thousands of dollars per year. That's the income bracket. Then ylab equals, and a pair of quote marks, and the y-axis label I want is percentage of households, comma, and then let's give a title to the graph that'll go overhead. We do that with the command main equals, and I'll just call the graph crime problem. And then let's give some ranges for the x and y axes. I'll say xlim equals range 0 to 100, so that's 100 thousands. And then ylim equals range 0 to 45. And we get this graph here, which is much nicer, right? You see the labels, income bracket, thousands of dollars per year, percentage of households, crime problem. This is a much more informative graph for a reader. Okay, that's the end of this lesson. Thanks for listening.